We continue. Question 17b, part 1 is saying complete the figure below so that it is symmetrical about AB. So when you are looking at symmetry, it means that you have a straight line which divides a shape into two identical shapes so that they fit on each other exactly. So AB is our mirror line. It means that the shape was folded along AB. So you have to count how many steps you're supposed to move in the X direction and how many steps you're supposed to move in the Y direction so that it will be able to fit on itself. So it will look something like that. So that is how it's going to look like. We go to part 2. Part 2 is saying state the order of rotation or symmetry of a regular hexagon. The word regular means all sides equal and all angles equal. A six-sided polygon is called a hexagon. So they are saying how many times are you supposed to rotate a six-sided polygon to fit on itself. So the order of rotation or symmetry is the number of sides that the polygon has. So we are saying order is equals to number of sides, which is 6. We continue. Question 18 is saying in the diagram below, AB is equals to 7 centimeters and AP is equals to X centimeters. Find X if AP is equals to 3PB. I'll read that again. In the diagram below, AB, so when you move from A to B, this is 7 centimeters and AP is X centimeters. Find X if AP is 3PB. So it means that if this is PB, AP is 3 of these. So we are saying from A to P we have 3, P to B we have 1. So if you add 3 plus 1, you are going to have 4 equal parts. So we are saying AP is equals to 3 of the whole line AB. So we are saying form a fraction which has been divided into 4 equal parts, but AP is 3 over 4 of the equal parts. So we are saying AP is equals to 3 over 4 of AB. Where there's AB here, we'll replace a 7. So we are saying X is equals to 3 over 4 times the whole line AB, which is 7. So if you multiply the numerators, 3 times 7 will give us a 21. And then our denominator is 4. Our X will be divide 4 into 21. You get a 5, remainder 1 over 4. So our X is equals to 5¼ centimeters. That is our answer. We continue. The translation vector 8, 12 maps the point n plus 3, 2 onto 2n minus 4, 14. Find the value of n. Now, a translation vector describes a movement in the x direction and in the y direction. So the object has to be added to the translation vector to get the image point. So we are saying the object plus the translation vector is equals to the image point. So we are going to substitute. Where there's the object, we'll put n plus 3 in the column vector form, and the 2 plus, put the translation vector should be equals to the image point, which is 2n minus 4, and then we have 14. So when you substitute them, what you're supposed to do is to solve what is on top on its own and solve what is on the bottom on its own. So we will solve for n. We'll say n plus 3 plus 8 should give us 2n minus 4. We'll call that one equation 1. If you look at 2, if you add 2 plus 12, it's going to give us a 14, which will give us a true statement. So for now, we have to solve for n. Let's do that. So we have n plus 3 plus 8 is equals to 2n minus 4. We'll group the like terms together. So if you transpose this negative 4 to the left side, it will become a positive. Transpose the positive n from the left side to the right, it will become a negative. From here, we can say 3 plus 8 plus 4 will give us a 15, and 2n minus n will give us an n. So therefore, n is equals to 15. For the equation 2, we already did that. If you add 2 plus 12, you are going to get a, if you add 2 plus 12, you get a 14. 14 is equals to 14, which is giving us a true statement. We continue. We have question 19, which is saying, for the inequality 4 divided by x is less than x divided by 4, find the least positive integer x. Find the least positive integer x. So integers are negative and positive numbers, including 0. So what we are going to do to solve this is we'll group the variables, the numbers on the left side, and then we'll put the inequality sign, which should give us a 0. So we'll solve it step by step. We are going to transpose the x divided by 4 to the left side and change the sign to negative. From here, what are we supposed to do? You have to find the common denominator. Which common denominator are we going to have between x and 4? It's going to give us a 4x. So since our common denominator is 4x here, we are going to divide the denominator into a common denominator times the numerator. So we are saying x into 4x is 4. Multiply 4 times 4, you get a 16. Put your minus sign. 4 into 4x, you remain with an x. X times our numerator x will give us x squared. From here, what are we going to do? We'll cross multiply. So if you multiply 4x times 0, you are going to get a 0. We'll just remain with 16 minus x squared. Now 16 minus x squared is a difference of 2 squares. If you express 16 as a square, it is the same as 4 squared. When you have a difference of 2 squares, it is the same as getting the difference of the bases times the sum of the bases. Let's do that. So this 16 here, express it in a square form. It is the same as 4 squared. 4 is our base. X is our base. Get the difference of the bases and the sum of the bases. So from here, we are going to get the first value here of x, and we'll also get the value of x from there. So we'll continue. We'll pick 4 minus x less than 0, or we'll pick 4 plus x less than 0. From here, what are we supposed to do? We are going to transpose the 4. If you transpose the 4, it will become a negative. Now, when you look at this one, the first inequality, if you have a negative coefficient here, there's a negative 1 before the x. If you divide both sides by negative, the sign has to change. It will change from less than to greater than. So we are going to say a positive x is greater than negative 4. So we are going to do that. Our positive x will be greater than 4, or this one will be maintained because the coefficient here was positive. So our solution set on the number line will look like that. So for all the values less than negative 4, they will be decreasing. For all the x values greater than positive 4, they will be increasing. So our least positive integer satisfying this inequality is a positive 5. And then the greatest negative integer satisfying this inequality is a negative 5, which is here.